Lakshmi Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. In this session, we will discuss about the architecture of 8051 microcontroller. So here, before going to the architecture, we will see first what is meant by microcontroller. So microcontroller is a small and low-cost microcomputer which is designed to perform a specific task of embedded system applications like displaying microwave oven information, receiving remote signals. Okay, so here generally microcontroller is used to perform a specific task. So if you take one embedded application, one big embedded application, it consists of multiple number of tasks. So if you take microwave oven for example, it consists of different tasks like displaying the temperature, rotating the dish in the microwave oven, adjusting the heat inside the microwave oven. So all these are different tasks that are involved in that particular application. So in order to execute each task, we should have one microcontroller inside that operation. So that is why we can say here microcontrollers are used to perform a specific task in a big embedded system applications. Now, so here microcontroller internally, it consists of some components. Here the components are processor, memory. So the memory may be either ROM, RAM or EPROM. And it also consists of serial ports and some peripherals like timers and counters. And it also consists of I/O ports. All these are different components that are present inside microcontroller. So all these components are embedded in the microcontroller. So based on the application, specific components can be used among all these components in a microcontroller. Now, so generally, microcontroller is called computer on a chip. So why it is called computer on a chip means, here the microcontroller, it has all the components embedded on a single chip. So all the components like processor, serial ports, I/O ports, ROM, RAM, timers and counters. So all these are different components that are embedded on a single chip, that are integrated on a single chip. So that is why microcontrollers are called computer on a chip. Now, so microcontroller are dedicated devices that are used in the embedded applications like microwave ovens. Okay, so dedicated devices means in the embedded system applications, it consists of individual tasks. Each individual task should consist of microcontroller. That is why these devices are called as dedicated devices. So it can perform only particular operation. Now, so among different types of microcontrollers, here we are going to learn in detail about 8051 microcontroller. So before going to the architecture, we will first see the features of 8051 microcontroller, like what is the inbuilt ROM and RAM sizes, and what is the size of address bus, data bus, how many number of serial ports are available, how many number of I/O ports are available. Okay, so all these comes under the features of 8051 microcontroller. So 8051 microcontroller is called 8-bit microcontroller. Why? Because it is having data bus size which is of 8-bit. So you will have data lines from D0 to D7. And address bus size is 16-bit. So we will have the address lines from A0 to A15. Okay. So here data lines are 8 and address lines are 16. So in some aspects we will have the address and data multiplexed lines as from AD0 to AD7, and remaining will be the demultiplexed address lines only, that is from A8 to A15. in the pin configuration. Now, so it consists of 4 register banks. So as we say in 8051 microcontroller, it is having more number of registers. Why? Because here it consists of 4 register banks. So here the 4 register banks are bank 0, bank 1, bank 2 and bank 3. Each bank consists of internally 8 registers, that is from R0 to R7. Okay. So here 4 register banks are there. Each register bank consists of 8 registers internally. Each register is having its own address in the address space of the RAM. So 8 4s 32. 32 registers can be taken from only register banks. So other than the registers in the register banks, we also have some other registers that are present in 8051 microcontroller. So here 32 general purpose registers. Okay, all the registers, general purpose registers is of 8-bit. And another feature is it is having program counter. It is also one register, and the program counter register size is 16-bit. And another register is DPTR, which is called data pointer, and this register size is of 16-bit only. So here program counter and DPTR, both the registers are having 16 bits. Now, so the amount of ROM that is available inside 8051 microcontroller is 4 kilobytes. So here generally ROM is called program memory. Why? Because the main program, whatever code we are writing, that will be stored in this ROM. So that is why ROM is called program memory. So the inbuilt program memory that is available in 8051 microcontroller is 4 kilobytes. And next one is RAM. So the inbuilt RAM that is available in 8051 microcontroller is 128 bytes. So here RAM is called data memory. So other than program, if there is any information available, that information will be stored in this RAM. That is why it is called as data memory. So these are the amount of memories, ROM and RAM, that is present inside 8051 microcontroller. So for example, if these sizes of memories are not enough, there is also possibility of connecting external ROM and RAM memories by using the I/O ports of 8051 microcontroller. Now, so in 8051 microcontroller, we have 2 timers available. Each timer is of 16-bit. And 4 8-bit ports are available. So totally 4 ports are available. Each port size is of 8-bit. So here the 4 ports are port 0, port 1, port 2 and port 3. All these 4 ports are bidirectional ports. Each port size is of 8-bit. And some more features of 8051 microcontroller. So how many number of interrupts that are available in 8051 microcontroller are? So it consists of 3 internal interrupts and 2 external interrupts. And it also consists of 1 serial communication port, which is called UART, Universal Asynchronous Receiver Transmitter. So this is mainly used for serial communication. Now, so here bit as well as byte addressable RAM area is available and its size is of 16 bytes. And so here machine cycle. So generally while discussing about 8086 microprocessor, in order to execute one instruction, it requires 4 clock cycles, T1, T2, T3 and T4. So that generally we call as instruction cycle or mission cycle. In the same way, if we come for 8051 microcontroller, in order to execute one instruction, we require 12 clock cycles. So the 12 clock cycles to execute one instruction can also be called as mission cycle. So this 12 clock cycles totally it will be divided into 6 states. Each state consists of 2 pulses P1 and P2. So all those are different features of 8051 microcontroller. Now coming to the architecture of 8051 microcontroller. So here architecture of 8051 microcontroller consists of different blocks. Okay. So here we can see in the previous session we have discussed about the pin configuration of 8051 microcontroller. Now, so here coming to the architecture, let us see what are all the blocks that are available in this architecture. So this is the first one, which is called the oscillator circuit. As we know, this is the oscillator circuit. The purpose is in order to produce the clock frequency for 8051 microcontroller. And so the clock frequency that is produced will be given to this timing and control unit. So the timing and control unit is going to take input from the oscillator. After taking the input from the oscillator, it is going to produce the timing and control signals. Here we can see different signals are connected to this timing and control block. The control signals are PSEN bar. Okay, so PSEN stands for program store enable. It is active low signal. Another control signal is ALE. So ALE stands for address latch enable. It is also an active low signal. And the next control signal is EA bar, which stands for external access. So this signal is also active low signal, which is used for accessing the external ROM and RAM. And another signal is RST. So RST stands for reset. So if this timing and control unit, if it gets input from the oscillator circuit, it is going to produce all these timing and control signals. So then after producing the timing and control signals, the instruction will be fetched and that instruction will be placed in this instruction register. So the instruction whatever is placed in the instruction register, then it goes for decoding. Now, so here generally we know there are 4 ports available in 8051 microcontroller. So here the 4 ports are, this is port 0 and another one, this is port 1 and next port is port 2 and this is port 3. So we can observe here each port size is of 8-bit. So here P0 stands for port 0, point 0. So this 0 represents that particular port bit size. Okay. So here 0 to 7, so port 0 is of 8-bit. And similarly here port 2, which is of 8-bit, and this is port 1 and port 3. So all these ports are 8-bit ports. So here also we can observe the direction of this bus. As we have seen, all these 4 ports are bidirectional ports. That means they can use as both the input and output terminal. So here clearly the direction is represented for all the ports, saying that they are the bidirectional ports. And so each port consists of its own driver and latch circuits. So we can observe here each port consists of its own driver and latch circuits. Okay. So now here there are some registers. So this is a program address register, which is used to store the address of the program. And this is a buffer. It is a simple register which is used to store the result. And it is a program counter which is used to store the address of the next instruction that is going to be executed. So after each instruction is executed, the program counter will be automatically incremented by 1. How means with the help of this PC increment. And this is a DPTR data pointer. It is a 16-bit register. So if you want, we can use this 16-bit register DPTR as two 8-bit registers, DPL, which consists of lower order 8 bits, and DPH, which consists of higher order 8 bits. And so along with this, we also have memory inside. So here we have ROM and RAM. So here this is ROM, and here you can see RAM. Okay. And so along with that, we also have some interrupt, serial port, timers and counters. And we have some general purpose registers like ACC. So here ACC stands for accumulator. So we can also represent this simply as A. And this is B register. And so after performing the operations, or if while writing the assembly language programs, if we wanted to store the data temporarily, inputs or any result, we can use the two registers like TEMPI1 and TEMPI2. These are the two temporary registers. And here we have ALU, that is Arithmetic and Logic Unit, which is used to do all the arithmetic and logical operations. So since this 8051 microcontroller is a 8-bit microcontroller, it will be performing all the arithmetic and logical operations only on 8-bit. So after performing the arithmetic and logical operations, the result again it will be stored in the registers, and the status of the ALU will be reflected on this PSW. So here PSW stands for program status word. So program status word can also be called as flag register. So the status of ALU will be reflected on this flag register. So the flag register size is also of 8-bit. ALU size is also 8-bit. So now we will discuss in detail about each block in the 8051 microcontroller architecture. Now, so here if we see the architecture, the first block is oscillator. So we will discuss about this oscillator circuit first. And next block is about the timing and control unit. So we will discuss this timing and control unit and all the control signals that are connected to this block. Next we will go for this instruction register. Okay, so like that we will discuss about each block in detail. So first one is here, on-chip oscillator. So what is the main purpose of the oscillator circuit? It is going to generate the clock pulses by which the internal operation takes place. That means clock oscillator is going to produce the clock frequency for the microcontroller. So if we recall the pin configuration of 8051 microcontroller, pin number 18 and pin number 19 or XTAL1 and XTAL2 signals. So here XTAL1 and XTAL2 stands for crystal oscillator. So by using these two signals of 8051 microcontroller, we are going to produce the clock frequency to 8051 microcontroller. Why? Because these two signals only will be connected to the quartz crystal oscillator circuit. So it takes the frequency from the oscillator circuit and gives to the 8051 microcontroller. Now, so here this is the basic circuit which we use to produce the clock frequency. So it consists of two capacitors. The two capacitor size is of 22 picofarad. Okay. So here the 18th and the 19th pin of 8051 microcontroller is XTAL1 and XTAL2. So using these two, this is the crystal which is used for producing the crystal frequency. Now, so in continuation to the oscillator circuit, so 12 oscillator clock pulses are required for one instruction cycle. So that means in order to execute one instruction, we require 12 clock cycles. So here the 12 clock cycles are present. So here this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So, or we can exclude this and we can consider, so the number of clock pulses will be here 12. Okay. So, why? Because here the clock pulses, 12 clock pulses are divided into 6 states here. So, here this is state 1, which consists of 2 pulses. So, this is 1 and 2, which is represented as P1 and P2. And state 2 also consists of 2 pulses, 3, 4, state 3, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So, 12 pulses are required to execute one instruction. We will call it as one machine cycle. So, the 12 clock pulses are divided into 6 states. That is state 1, state 2, so on up to state 6. So, each state consists of 2 pulses P1 and P2. Okay. So, these 12 pulses will be produced by the oscillator circuit. And so, oscillator circuit will produce the oscillating frequency, that is clock pulses, and then it is going to give it for the next block, which is called timing and control unit. So, this timing and control unit take input from the oscillator circuit and it is going to produce the timing and control signals. So, here the timing and control signals are ALE, PSEN, okay, EA, RST. So, all these are the timing and control signals that will be produced by this timing and control unit. So, first one is here ALE. So, ALE stands for address latch enable. So, generally this is active low signal. So, what is the main purpose of this ALE signal means? When this ALE signal is enabled, the purpose of it is used to fetch the instruction from the memory. So, fetching can be performed. After one instruction is fetched, in order to fetch another byte of data, what it has to do means, it has to enable again one ALE signal. So, if you take here, this is one machine cycle which consists of 12 pulses. Okay. So, when this is the ALE signal, when this ALE signal is enabled, okay, so ALE is active low signal. Okay, active low signal means in order to enable it should be active low. Okay, so in order to enable it should be active low. So, when it is enabled, one instruction will be fetched. In order to fetch another instruction, another time the ALE signal should be enabled. And another control signal is here PSEN bar. So, PSEN stands for program store enable. So, this is also active low signal. So, when the device is executing the code from the external memory, then this PSEN signal is activated. Okay. So, this is the control signal. When it will be activated means during external memory access. And next control signal is EA bar. Here EA bar stands for external access. So, this is related to the ROM memory. So, when this EA bar signal will be enabled means, so this is active low signal. Enabling it means when it is active low, it emits AD0 to AD7 on port 0 and A8 to A15 on port 2. So, as we know here, port 0 and port 2 are having dual operations. That means port 0 can be used as IO port and port 0 can be used as address data multiplexer lines. Similarly, port 2 can be used as IO port and port 2 can also be used as simple address lines. Okay. So, in which case they should act as IO lines and in which case they should act as address lines or address data lines means it is dependent on this external access signal. So, when it is low, port 0 will be used as address data lines and port 2 will be used as address lines. Another control signal is reset. So, in the block diagram, it is represented as RST. So a high on this pin reset 8051 microcontroller. So it should be high for 2 machine cycle while the clock is running. So for each 2 machine cycles, this RESET or RST signal should be enabled. Now, next 8051 registers. So number of registers are there as we have seen: instruction address register, program counter, stack pointer, okay, accumulator, ACC, B register. All these are different registers that are available in the architecture. Now, coming to 8051 registers in the block diagram, we have observed one register is instruction register. So what is the main purpose of this instruction register? So this register holds the instruction which need to be decoded. So after fetching the instruction, it will be placed in the instruction register. In order to decode that particular instruction, it will be taken from this instruction register. Then it will be decoded. And next instruction is program incrementer. So a 16-bit register keeps incrementing the address in accordance to the program flow. And this is used to facilitate PC to be used for addressing modes. That means we have PC register. After PC register in the block diagram, we have program incrementer. So program counter holds the address of the next instruction that is going to be fetched. After each instruction is fetched, the program counter will be incremented by 1 with the help of this program incrementer. It is a 16-bit register. And next is program address register. So this is a register which is used to store the address of the program, or you can also call it as code that should be accessed. So here this program address register is also a 16-bit register. Now, so here program counter holds the address of the application to the address bus pins. And next register is program counter, which we can also represent it as PC. So what this PC, program counter register, holds means this is also a 16-bit register. So 16-bit register which sequences the instruction. That means because it holds the address of the next instruction that is going to be executed, so all the instructions will be executed in the sequence manner. So at any time it points to the address of the next instruction that is going to be fetched. So instructions can be stored in ROM. That is why PC is pointed to ROM only. And next register that is available in the 8051 registers are DPTR. So DPTR stands for data pointer. So this register is also 16-bit register. So here, if you want to perform any 8-bit operations, we can use this 16-bit register as 2 8-bit registers. So the 2 8-bit registers can be represented as DPH and DPL. So here DP stands for data pointer, whereas L represents lower 8 bits and H represents higher 8 bits. So DPTR used as pointer for accessing internal ROM and also for external memory. Now, so RAM address register. Like we have seen in the previous slide, program address register. So that register is used to hold the address of the code or program. Similarly here, RAM address register means this is a register which holds the address of the data reference, because ROM will be holding the program, whereas here RAM will be called as data memory. That is why it will be handling the data. So this is used while move instruction is executing. Why? Because this is the data transfer instruction. So along with those registers, we have two temporary registers in the architecture, that is TEMP1 and TEMP2. So here TEMP stands for temporary. So two temporary registers are available. Okay. So these temporary registers are used to store the data temporarily. For example, if you are performing any operations like comparison operation, okay, after comparison operation, generally we will not store the result anywhere. But if we want to store the result anywhere, we can use these two temporary registers. Okay. So use the contents of registers, but do not alter their content. Just it is going to store the data temporarily. So during storing of data temporarily, any operations, we can use the two registers TMP1 and TEMP2. And another registers are ACC. So here ACC stands for accumulator. So simply it can also be represented as A. So this ACC or A, it is a register which is of 8-bit register. So generally this register A, B, these are the registers that will be used very frequently. So the most important data register is accumulator, which can be represented as A. So while performing any arithmetic operations, we need to take two operands as inputs. So while taking the two operands as input, we can store one operand in the register A. So other operand what you can take may be either kept in the RAM or in any other registers like B. So another register is B register, which is also called as base register. This is also an 8-bit register. So this register is used as operand only for some specific operations like multiplication and division. So if you perform multiplication operation, so 8 by 8 multiplication, the result will be greater than 8-bit. Okay. So if the result is greater than 8-bit, the extra result, that is MSB, will be stored in this B register. If you are performing any division operation, we are going to get the quotient. So that quotient result and all will be stored in this B register. So for example, if we take for multiplication of two numbers, one operand we are going to take in the register A and the other operand we are going to take in register B. And so as I have said, in 8051 microcontroller, there are more number of registers because here register banks are available. Okay. So 4 register banks are available. Bank 0, Bank 1, Bank 2 and Bank 3. Each bank consists of 8 registers. Here the 8 registers are R02 to R7. Okay. So these 8 registers that are present in the register banks can be used as simple general purpose data registers. So 4 set of registers are there which are called as register banks. 4 register banks are there. So though there are 4 register banks available, at a time only one bank can be used, operated. Now, so first 32 bytes from allocation 00 to 1FH are used as register banks. So we will see here what is this 00 to 1FH. So there are 4 register banks. Each register bank consists of 8 registers. So A register is addressed as internal memory 0E0H. So here though there are 32 registers available in the register banks, in order to access any register from any bank, it is possible. Why? Because each register is having its own memory address. Okay. So similarly, like if you take A register, we can access the A register internally from the RAM by using the address called 0E0H. Similarly, B register is having the address 0F0H. So if you see here, these are the 4 register banks that are available. So bank 0, bank 1, bank 2 and bank 3. Each bank consists of 8 registers. So here the registers R0 to R7. Okay. So this bank 1 also R0 to R7. Similarly, in the other 2 banks also we have registers from R0 to R7. So each register is having its own address. So here for a register R0 which is present in bank 0, it can be accessed by using the address 0, 0. So in order to access this R5 register present in bank 0, it is possible by using the address called 0, 5. Okay. So similarly, we have different addresses for each register related to 4 banks. So all the registers are ranging from the address 00 to 1F maximum. So at a time only one bank is accessible. So how to access that bank means by using all these addresses of particular registers. Now, so after performing the arithmetic and logical operations, the result of ALU will be reflected on the flag register. Here the flag register can also be called as PSW. So PSW means program status word. So it is a 8-bit register. Okay. So it consists of different flags. All the flags will be changed based on this bank switching, because in the flag register we have 2 bits that are related to the bank switching. So these RS0 and RS1 bits will say which bank to be selected. We have 4 register banks. One of the bank will be selected by using these 2 bits in the flag register. Now, so as we know here, flag register consists of 8 bits. The 8 bits are here. First one is P. So here P stands for parity bit. Okay. So after performing any arithmetic and logical operations, if the result of ALU, if it consists of even number of ones in the lower nibble, then we say that the parity bit is set. And another flag is here, it is not defined. And next one is OV, which says overflow. Okay. So for example, if you are performing any 8-bit operations, but the result what we got is more than 8-bit. That means if it is not able to fit in the register size, then we say that the overflow flag bit is set. And this RS0 and RS1, these 2 will select the register banks. And next bit is here, F0. It is related to flag bit. And this is AC, which is called auxiliary carry. If there is any carry from lower nibble to higher nibble, or if there is any borrow from higher nibble to lower nibble, then this auxiliary carry flag bit will be set. And another one is here, CY. CY represents carry flag. Now, so as we have seen, CY represents carry flag and AC is auxiliary carry flag, and this is a F0 bit which says flag 0. It is available for user general purpose. And next 2 bits RS0 and RS1, they are used for selecting the register bank. So we have 4 register banks. And OV, it stands for overflow flag. And next here, this is the bit which is not defined. And here P represents parity flag. And now coming to these 2 bits RS0 and RS1 in which are available in the PSW, they are used for selecting the register banks. So by using these 2 bits of program status word, that is flag register. If this RS1 and RS2, so which you can represent here RS0 and RS1. If these two are 0, 0, register bank 0 will be selected. Register bank 0 consists of 8 registers, that is from R0 to R7. Okay, R0 address, register address is 00 and R7 register address is 07. And if this is 01, register bank 1 will be selected, bank 1 will be selected, and it is having the address range for 8 registers R0 to R7 as 08 to 0F. And if it is 10, register bank 2 will be selected. It is having the address from 10 to 17H. If both are 1, register bank 3 will be selected and it is having the address 18H to 1FH. So these are the 2 bits that will select the register bank. After accessing that register bank, any among 8 registers will be accessed by using the address. Now, and another registers available in 8051 microcontroller is SP. So here SP stands for stack pointer. So as we know, it is a 8-bit register. Okay, always it stores the address of the top of the stack. And so that is what about 8051 registers. After that we have memory available in the architecture. So here we have RAM and ROM. So here internal RAM. So internally the amount of RAM that is available inside 8051 microcontroller is about 256 bytes. And among these 256 bytes of internal RAM, half of that 256 amount of memory, it is reserved for SFRs, which is called special function registers. Okay, so these special function registers are used to handle the activities that are done with the help of some peripheral devices. And so half of it means 128 bytes. Okay, among 256 bytes of RAM, 128 bytes of RAM is meant for the special function registers and the remaining 128 bytes is meant for internal RAM. Now, so here in the internal RAM, it consists of 4 register banks, that is from bank 0 to bank 3. Each bank consists of 8 registers R0 to R7. And each, so if you consider here R0, its address will be 00. And if you consider here R7 of bank 4, its maximum address will be 1F. And so 22 to FH, this region of memory is considered as 16 bytes. And whereas 30H to 7FH, it is addressable memory general purpose area for data stack. So that is how the internal RAM is being divided. Now coming to the internal ROM, that is read-only memory, we will see now what is the internal ROM available and how it is being divided. So internally 8051 microcontroller is having 4 kilobytes of ROM, okay, and its address will be varying and starting from 0000H to 0FFFH. Now, so what is the main purpose of this ROM means? ROM represents program memory, okay. So that is why this ROM memory, it is used for storing the final code that the application is to be needed. So that is why ROM is called program memory. And Some part of the ROM can also be used to store the data. So there are instructions that allows to access ROM during the programming. Now, so here internal ROM, the maximum possible amount of ROM is 64 kilobytes. And once a design is tested and finalized, the code will be burned into the ROM, because final code will be final code that is given to the application should be present in the ROM. Now, so that is what about internal RAM and ROM in the architecture of 8051. Now coming to 8051 ports, it consists of 4 ports: port 0, port 1, port 2 and port 3. Each port is of 8-bit in size. Now, so coming to port 0, as we know, each port is having 2 functions except port 1. So port 0, if this EA bar signal, as we know, EA bar means external access. So based on that external access signal only, it will decide whether it has to act as port pins or it has to act as some other pins like address pins, address data lines or some other function. So coming to port 0, if EA bar signal is logic high, it function as IO port. If that external access signal is active low, it will function as multiplexed address data lines. Now coming to port 1, same, it has also 8 pins, but it is not having 2 functions. It is meant only for IO port pins only. It is not having any dual operation. That is why those ports are called as dedicated IO port. Now coming to port 2, it is having 2 functions. It is 8-bit port. So the 2 functions are, it acts as input-output port pins and it will also act as simple address lines. So if this EA bar signal is high, port 2 pins will be acting as IO pins. If that EA bar signal is logic low, the 8 pins will be acting as address lines. Now, coming to port 3, it is also having 2 functions. Each signal will be having a different operation. So for port 3, if this EA bar signal is logic high, it will be acting as simple IO port. If EA bar signal is active low, it will be performing different operations like read, write, transmit, receive, timer signals, interrupt signals, like that. So some of the signals will be having other operations like port pin. Okay, so what are other operations means? So it is having receive data, transmit data, 2 interrupt signals. It also consists of 2 timer signals and read and write operation. So these are other operations of port 3 pins. Now, and another unit that is available in the architecture of 8051 microcontroller is, it has ALU. So ALU stands for Arithmetic and Logic Unit, which is used to do all the operations on 8-bit only. Now, so it has special function Boolean processing. Now, while performing as Boolean processor, it works as 1-bit ALU. So this is what about the architecture of 8051 microcontroller. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.